Hello, welcome back. We're now going to do game 5 of the Class Notes Handout 2. So again, as always, please try and do this on your own before you hear my explanation. All right, let's begin. First, how many dominant strategies are there in this game? How many did you find? Let's look. Player 1, nature picks left. If he goes up, he could get 7 or 0. If he goes down, he's going to get 1. Well, we can't be sure. We don't know what player 1, if he's a lefty, we don't know if he's better off going up or down until we figured out what player 2 is going to do, meaning player 1, if he's a lefty, has no dominant strategy. All right, what if player 2 is a righty? Nature moves this way. Player 2 is a righty. He says, well, if I go up, I could get 8 or 2. And if I could go down, I would get 5 or 3. We can't be sure, right? It's possible up gives you 8, while down would give you 5. Possible up is better, but it's also possible up would give you 2 and down would give you, well, 5 or 3. So down would be better. No dominant strategy for player 1. Now let's look at player 2. If up is played, player 2 will not know if he's here or here. He'll say, well, look, if I knew I was here, I would want Y. If I knew I was here, I would also want Y. Dominant strategy, right? If player 2 has been told up is played, player 2 will say, I'm somewhere in this oval, and I know no matter where I am in this oval, I am better off with Y, because 7 beats 0, and 7 also beats 6. So player 2, if up is played, does not have to worry about what player 1 is going to do, because he's always better off with Y. Now, what if down is played? You're player 2. You say, well, look, if I knew I was on the left, I'd want X. And if I knew I was on the right, I would want Y. So player 2, if down is played, does not have a dominant strategy. Okay, what's the next step? Well, these are puzzles with 4 pieces. And sometimes finding one piece makes it easier to find another. So we've gone through our dominant strategy situation. What does this help us figure out anything else? Well, yeah, it does. Player 1 is a lefty. He knows up is going to be met with Y because, if up is played, Y is a dominant strategy. He also knows that down is going to be met with, well, it doesn't really matter, you get one either way, but down is better. So player 1, if he is a lefty, is going to want down because he realizes that going up always leads to him getting 0. Now, can we do the same thing here? If player 1 is a righty, he knows up gives him 2. Down gives him, oh, look, more than 2. We don't know how much more, but it's still more. So once we know that player 2, if up is played, has a dominant strategy of Y, we know what player 1's going to do. All right, we have one final piece of the puzzle. We've got to figure out what player 2 wants to do if down is played. Now, down is played, and it's going to be played. We figured out player 1's always going to go down. Player 2 realizes he's in a pooling equilibrium. He's like, I expect everyone to play down, so I can't figure out from what player 1 does where I am, whether I'm on the left or the right. So player 1 will say, what I know is if nature went left, which happens 75% of the time, player 1 will play down, and so I'll be here 75% of the time. If nature plays right, player 1 will play down, and I'll be here. And I'll be here 25% of the time. So player 2 has to estimate which gives him, on average, a higher payoff, playing X or Y. You play X when down is played, you get your player 2, you get 1 with probability 0.75 and 0 with probability 0.25. So of course that comes out to an average payoff of 0.75. If you play Y when down is played, you estimate you get 0 with probability 0.75 and 1 with probability 0.25. And that of course comes out to be 0.25. So X is the winner. If down is played, player 2 wants to go with X. And so that means if nature goes left, we go down, we go X, and everyone gets 1. Nature goes right, we go down, we go X, and player 1 gets 5, and player 2 gets 0. So for this game, 75% chance we end up here, 25% chance we end up here, and this is a pooling equilibrium. Thank you. Goodbye.